In this video, we will see how to use TreeSet. TreeSet belongs to the Java collection framework, and as you can see from this UML diagram, it is a sorted set. So TreeSet extends navigable set, which extends sorted set. That means if we add an element to the TreeSet, the TreeSet will maintain the sorting order based on their natural ordering. And it can sort the elements based on a comparator as well. So if you don't understand comparable or comparator, Java sorting in general, then I would suggest please watch my videos on the same topic before moving on. Okay, so let's see how do we create a tree set, how do we add elements, and how does it maintain the sorting order. To create a tree set, we use the class TreeSet and we initialize same as any other class. We provide a data type, that means we are going to add integers in this tree set. Then we initialize the class using default constructor. So that's how we create a new tree set. To add the elements, we simply call s.add. That means add method on the tree set. Let's add bunch of elements randomly so that we can see the sorting order. And duplicates as well, because the property of the set is that it does not allow duplicates. So we added one duplicate with 3 value, then 2, then 1, then 4. So you can see there is no order, there is no sequence of these numbers. Okay. But now if we simply print the set, we should see numbers in sequence in their ascending order, because that is the natural ordering of numbers. So we see 1, 2, 3, and 4. It not only sorted the numbers, but it also removed the duplicate. Next, we will see how to add a custom class to a tree set. So let's create a custom class. Student, it will have two properties. And let's override toString method. Okay. And let's add a separator. So I'm going to create a new tree set, but this time it will store students equals to new tree set. And then we will say students.add the student. So I'm going to create a new student, pass it an ID, and then a name. Then I'm going to create another duplicate student, and the expectation is that set won't allow this duplicate student, and in the output we will see a single student with ID 1 and student name S1. Then few more, let's say 3, yes, and then 2. So what we are doing, we added 4 students, there is one duplicate, and then there is no order of students. All right. This time if we print this set and run the program, we see an exception that this student cannot be cast to comparable. So if you remember the discussion from the comparable video, that in case of a custom class, if it does not implement comparable or comparator, then Java has no idea how to sort them because it cannot compare them. So if we need to define the natural ordering, what we can do, we can simply implement the comparable interface, or we can pass it a comparator. if we don't want to define the natural ordering, or the entity does not have a natural ordering, then we can pass a custom comparator to the tree set, and it will be able to sort the elements based on that comparator. So let's implement the comparable interface. And we are saying the natural order of the student entity will be by name. It means if we don't provide any explicit criteria, the student will be sorted based on their name. So let's do that. Let's implement the methods from the interface, which is a single method compare to. Okay, it must be comparable first of all. And here I would say this dot name dot compare to o dot name. So I'm comparing names. I'm simply calling the compare to method of the string to compare two strings, because name is a string property. Let's run the same program again. Okay, so this time we see the students have been sorted based on their name, S1, S2, and S3. And we also don't see the duplicate. Although we have not overridden the equals method, but still set did not allow the duplicate element. How is that possible? So in case of sorted collections like sorted set and sorted map, what they do, they generally use the compare to method of the entity, all right, to sort the elements, to compare the elements, and based on this it was able to figure out the duplicate. But still it is a best practice that your equals and compare to methods must be consistent with each other. It means if two entities are equal based on their equals method, then they must also be equal based on their compare to method, and vice versa. So in this case, although it's a sorted set and it will be able to figure out the duplicate based on their compare to, but as a best practice we will still override toString and hash code. Sorry, equals and hash code, not toString. So equals we understand, but why hash code? Because internally TreeSet uses tree maps. All the set variants, they use their corresponding map counterparts. So it's important that we correctly override hash code and equals. Okay, so here we saw how to use a custom class using natural sorting. Let's move on and see how to use a set with a custom comparator. So let's create a new tree set of type student. And as you can see, there is a constructor that accepts a comparator. Okay, so let's pass a comparator this time. What we are saying that we have the natural sorting or natural ordering based on the name using comparable. But what if we want to sort the elements by ID this time? To do that, we will pass a comparator that will sort the elements based on their ID. So we say comparator.comparing, it accepts a function. And before that, let me also generate getters and setters. So we have now getters and setters for ID. So what I'm going to do is I'm simply going to pass a method reference, and I will use the method reference for ID attribute. So what I'm saying that create a comparator to compare the entities based on their ID. And let me repeat the same thing again. But this time let me change the IDs so that it is visible that the students have been sorted based on their ID. So 111, this is a duplicate, and let's change the name to something else. Another student, and yet another student. And this time we will see the students in order in the sequence of their IDs, which is this one 1 followed by 2 followed by 3. So let's print this set now. S1 also a separator and run the program. Oh, I made a mistake because although I created a new set, but I'm still adding the elements to the old set. Okay, it's a copy paste mistake. Let me correct that. So S1. So we see that students have been sorted based on their ID. We see ID 1 first, followed by 2 and followed by 3. Apart from this, everything remains the same. Whatever we covered in the set video applies here as well. Alright, whether it is to check the key using contains method or anything else. Let's quickly see other properties of the tree set. So if we go to the tree set documentation from the Java source code, we see that it implements the navigable set, which is an interface. And if we go to the navigable interface, then we see it extends sorted set, which is another interface. So sorted set is an interface that defines the contract or methods of a set that must sort its elements. So we have methods like comparator to compare the entities. Subset is basically to get the subset of a set that we created between these two elements. So this is the low element and this is the high element because it is sorted. So we may get a subset between two numbers or two entities. Similarly, we have methods like headset. Basically, then we have methods like tailset. In this method, for example, we can get a set in which all the elements are greater than or equal to this element that we provide. So it's a tail set. Similarly, we can get the lowest element based on their sorting order. We can get the highest element based on the sorting order. Going back to the navigable set, if you go to the documentation, so it is a sorted set and it extends with navigation methods. So that means we can also perform range queries on this set. We can get the lower, we can get the floor and ceiling and higher, pole first, pole last. So if we want to perform the range queries, we can do that using TreeSet. All right. So that's pretty much it on the TreeSet.